This webinar explores how to build and maintain a secure AI-ready data infrastructure.
So the key to fueling your AI is really quality, quantity, and security. So what I'm going to talk about is those three pillars and how getting the right data and putting security around that data is very, very important. Some of the things we're going to talk about are redundant, obsolete, and trivial content, which makes up, whether you believe it or not, probably the vast majority of data that you tend to have in your organization. How to control what goes inside these models, how to control what comes outside of these models, and then how to build what we call an AI ready data environment or infrastructure. So let's look at kind of a typical AI infrastructure. So as I mentioned, the bulk of what is going to be feeding or training these LLMs is your data. And unfortunately, the data is everywhere. So like I said, the bulk of what we have in our organizations is unstructured data. Word documents, PDFs, they could be CAD drawings, it could be video files, whatever it is, that tends to be the bulk of the data. And the problem is it's everywhere, and most of us don't know what it is, where it is. We don't know who has access to it. We don't know if it's dated. We don't know if it's valid or valuable data. So whether you're using a private LLM, and private can be something that you built completely on your own, or it could be something like your own enterprise tenant of Microsoft Copilot as an example, or if you are using the 100 or so, it's probably like 1,000 at this point, public LLMs that are out there, whether it's ChatGPT or a public instance of Copilot, or again, lots and lots of different scenarios. Whether you're using an internal or an external LLM as part of your AI projects, you want to put some type of governance around that. And governance usually means that you are trying to put up some type of a control as to what goes into the LLM. So a lot of organizations have what they'll refer to as guardrails, which are policies that will help your employees understand what kinds of information they should and should not be putting into LLMs. If you are working with a private LLM, then you also have to have some kind of an infrastructure to support that. So this could be a combination of private cloud-based infrastructures, which a lot of companies are using just because they can scale easier. You might have on-premises systems, and you might have hybrid systems. So if a lot of your data is sitting, let's say, in on-premise systems, you probably have a hybrid. So this is kind of a typical scenario, when people are looking at AI infrastructures. As I mentioned, the issue today is what is the right data? And right data, has a lot of different meanings to different people. So as I mentioned, what is the data? And in an organization, probably 20 to 30% of the data that you have might be current and relevant and quality. Give an example. If you are building a private LLM because you want to automate and improve your contracting process, maybe you have a very extensive supply chain. You could be in a manufacturing business, you could be in oil and gas, and you need to really hype up that contract process to make it a lot more efficient. So what you need to do is find a lot of examples of contracts. The problem with that is if you think about the normal flow that you might have with a document. Say somebody in one department creates a document, they then hand that off to another person. They make some edits, they hand that off to a third person. Those three people might store this data in a variety of places. It could be email, it could be a cloud, it could be on their phone. And at one point, you now say, what is the good contract? What is the right data for that particular process? So I have a lot of data, maybe 80% of that is no longer valid because they're just different versions until you get to the proper contract. So that's a lot of the issue that we have here. What is it? Where is it? Is it current? And is it relevant? So these are a lot of the issues that we need to concern ourselves with. So let's look at the three pillars that I was talking about: quantity, quality, and security. So if we talk about quantity, let me go back to the example that I mentioned with a contract. So you could have a contract department that you want to create your own LLM, or perhaps there could be a lot of other things. You could be in manufacturing and you want to use an LLM to speed up the processes that you use within your manufacturing. So finding, again, the relevant data can be a bit of a challenge. And one of the issues that a lot of organizations have today is they have so many locations for data. Most organizations are taking advantage of cloud. Cloud has a lot of advantages when it comes to cost and efficiency and scalability. So a lot of data might be up in there. You also have scenarios where, as people roll out different projects over the years, they might have test data in different locations, or they might have dev environments. And then we have data that sits on our own laptops. We have data that sits on servers. We could have data that sits on our phones. So a lot of different problems with finding the data. So you have data, but you have to get the right data. And to feed an LLI model, you need a lot of data. Next thing, as I keep alluding to, is quality of data. So if I have 10 versions of a contract, one of them is probably the correct one. That is the relevant data that I may want to use to feed my model. The other 9 have outdated information. They could be considered redundant. They could be obsolete. You also have a lot of data that may be trivial data. Just because data sits in a location doesn't mean there's value, there's business value to that particular data. So, there's the adage of garbage in, garbage out. If you just start feeding a lot of data that isn't quality data into your LLMs, you're just going to get a lot of garbage out. The last piece is on the security side. So one of the issues that all of us have is who should have access to data. You can think of this in a couple of different ways. There's sensitive data inside an organization. It could be PII, which is probably the best example, or maybe there's certain trade secrets that you can't nor should you put into your LLM. So I don't want to have, a US Social Security number or a credit card or a social insurance number even inside my private LLM, because controlling who would then be able to extract out of that with a simple prompt, becomes a challenge. So what you want to make sure is that you control data that goes into your LLM. So there should be some kind of an access control list that is around your data. Once you have defined that access control list, then you have a better understanding of what information should go into the model. And then as data comes out via prompts, you also probably want to put some type of access control around it. Because again, not all data that comes out of these models is necessarily for everybody in the organization. If we look at a conventional cloud infrastructure, this is what a lot of people are looking. They might have an ECM system, and there are a lot of ECM vendors who will say, well, all of your data is sitting in our ECM, in your tenant. And so that is a good way to start feeding your model. Is that in fact AI-ready data? The problem is, as I said before, the data can be very fragmented, and you have a lot of redundant data. You have localized copies, which we all do. If you're using something like, let's say, Microsoft SharePoint Online, everybody downloads the data and you have copies that are local. And yes, there are plenty of mechanisms in place that hopefully your employees are following to upload and get the current data. But the reality is that there's a lot of redundant data that's around, and it may not be the single source of truth, if you will, sitting inside your ECM. So that's one question. The next question is there anything that's missing? So just because the data is sitting in my ECM system, that doesn't mean that is where all the valuable data is. I'll go back to the contracts example. There's a lot of people that will use varied systems when they're doing contract management. They might have an ECM, they could have other systems, including something like a Salesforce or another CRM system. And so the question is it valuable? Is it the right data? Is it all the data? And so when you start thinking about AI-ready data, you want to use the term curated. So I have a pile of data, 80% of it is probably not of any value to me. I want to make sure that the data I have is valuable. And one of the ways to address that is with the metadata that's around these particular documents. So if you think about looking at metadata on a document, it would tell you things like version numbers, perhaps, or it might tell you the last time a document was updated or the last time a document was used. These are all ways to give you clues to help you curate the data to make sure that it is, in fact, valuable data. So one of the approaches that we have to this is what we call content virtualization. And what happens in this case is every document gets what we call a persistent identifier or a virtual ID or a content ID. They're kind of interchangeable. And as each document has that identifier travels with the document. If I make a copy of the document, so now I have version 1, 2, 3, I still have that virtual identifier, and I have metadata that's inside there, which is going to alert me to the fact of the particular version. So it's very easy by using a metadata-based approach to understand what is current and then what is valuable. And regardless of where that particular document goes, that's why we call it content virtualization. We are linking all of these virtual IDs together. So part of that process is there is an access control list that's associated with those particular documents. And this way I can control who accesses that information. I have version numbers, so I know what is the current version. And then I will have usage logs, which will give me some indication of data lineage. And data lineage is a term for those of you who are familiar with things like the GDPR rules in Europe. A lot of people talk about data lineage because what they want to understand is where did this document come from and who touched it. And that, again, is a key piece of information to help you come up with the right type of data. The other key thing about the virtual ID is it is location agnostic. And so part of the importance of tracking your data is you don't want to worry about where it goes. So if you think about today trying to wrangle all the locations you have of your data, you might have multiple cloud environments, you might have a lot of on-prem, you obviously have devices that people are using, whether they're corporate-owned devices or BYOD type of devices. And most of us have some type of security that is around the device. Maybe it's an MDM system on your phone, could be a CASB in the cloud, just some type of a way to control that particular access. But the problem with all of that is you wind up playing whack-a-mole. And what I mean by that is as soon as you plug one location, somehow another location pops up. People are very creative. If they want to move data around, they figure out a way to do it. So by virtualizing the content here, you're not so much worried about where the data is because all you're really focusing on is the particular documents and who has access to them and what is the current version of them. If we look at this in the context of our quantity, quality, and security paradigm, what we're doing with this content virtualization is we are giving a rich set of metadata, as I showed in the previous slide. Who has access to the information? What is the current version of that information? Who has accessed it last? So this gives you a better understanding of what is, in fact, good data. And that's what we refer to as an AI-ready data infrastructure, to be able to make sense of all the data that you will need, focusing on the quality of it to make sure you get the right data, getting a large enough quantity of that data so that you can feed your models and get very good information out of it, and then worrying about the security of that data, because again, not everybody should have access to the particular information. Now, as you build your models, when people are using the model, there's another set of controls that you need to think about. I mentioned PII as an example. So let's say you're using a public model. You want to make sure that your employees, when they're putting data into the prompts, they are not putting in PII or anything sensitive. AI is fantastic for summarizing, for coming up with examples of how to do things. I know a lot of developers will use it. And it's one thing to ask a public model about how to do something generally, but it's another one to actually input your proprietary source code up there and ask the model to take some action on it. So in the side of input, one of the things you want to focus on is filtering and inspecting what goes up into there. So one approach is to have a set of rules that as people go to these particular sites, like ChatGPT, for example, you can have filtering in there, and it will be able to either alert that user to a violation of policy, such as you're trying to put PII into the model, or in fact, it could block it completely. So some of this is technologically based, some of this is behavioral based, where you're trying to, help people who want to get the value out of using the LLM, but you want to make sure that your proprietary data doesn't go up in there. The other issue, which most of us haven't focused as much on, is really output management, or what we call data hygiene control. So there's a couple of areas of major concern. One is if you are going to get data out of these models, how can you validate? How do you know that, in fact, what it is saying is correct? Have you infringed a copyright? Is there bias in there that you need to guard against? So some of the things that I know a number of the providers have done is they have added some type of an identifier. Now, ChatGPT talked about adding watermarks and different elements into the output of these models. So it's a lot easier for an organization to determine, is the data purely out of a model? Has a person done any curation on it? And is that particular information, valid? So these are some of the things that are very much, on the mind of most people. Controlling output to make sure that you only get what you're expecting, controlling input to make sure that you're not feeding, especially a public model, any type of proprietary information. This brings us to the concept of what we refer to as advanced data security. Now, traditional data security tends to be what we call location-based. And I mentioned this earlier. So in all organizations, if you're doing things on-prem, you have some type of an access control list, whether it's into an ECM, whether it's a folder-based sitting on a window share or a NAS, there is some kind of security that will limit people from accessing certain types of information. The problem with that is that if I take that data out of that location, then all of those security controls are no longer valid. So let's say I had access to a finance folder and I pull a salary document out of there and I put it on my endpoint in my desktop. Well, the security controls that were on the folder do not follow me to my desktop, and I could potentially share that with anybody. So the problem you get into is that if you're focused on location, like I said earlier, then you have challenges here because, again, it's like whack-a-mole. It's very easy to circumvent by saying to your friend, hey, you have access to this. Can you just email it to me? The other problem with a traditional location-based security is consistency between locations. So you might have consistency, let's say if you're doing internally shared folders, maybe there's consistency and you have a governance group that does a good job, but a lot of times different departments may have different controls. When you get into your cloud repositories, you might have the same problem. There might be inconsistencies between the different security controls you have. And then the persistence, as I said earlier, once I take it out of location A and I put it in location B, I don't any longer have the security I had in location A. So what advanced data security does is rather than focusing on location, what we're going to focus on is the data itself. So what this means is that rather than using a lot of different fragmented tools, as I mentioned, I could have an ACL on a file share internally. I have an ACL inside my SharePoint Online. I have a CASB that's going to control access to different cloud scenarios. Rather than doing that, advanced data security provides a integrated platform that really focuses, again, on the data, not on the location. So by doing that, I could say, I am going to focus on controlling access to a Word document or a PDF or a CAD drawing. And by putting the controls on the document itself, I have consistency because it doesn't matter where that particular document travels. I have persistence because the security is always with that particular document. And I have a lot of controls because every time a user tries to access that particular document, only an authorized user has access. And I can, as an administrator or a data owner, I will be able to change or alter those security policies depending on business requirements. So if I had that scenario where I have people in HR and I might have people in the finance group, if somebody is now in one group and moves to another, my policy can accommodate that to say that the person is no longer in finance, they should no longer have access to that particular types of information. The other piece of that is that as users work with these documents, the organization has a much better visibility into what we call posture management. So posture management is really an understanding of what your data is, where it is, and who has access to it. So by controlling and tracking all of that, we have a much better understanding of what the data is, where is it, and then based on that, it's very easy for us to determine what is valuable. Other key pieces of that control would be using advanced encryption techniques so that if that information were to be exfiltrated, you could think of two scenarios. One is somebody tries to upload an encrypted file, let's say, into a public LLM like ChatGPT. Well, ChatGPT won't be able to read that. So you now have, by default, controlled the ability for somebody to put sensitive information in there. The other scenario is if somebody, a bad actor, either externally or you might have an insider threat, if that data were to get out of the organization, the people on the outside would not have any access to it. So what we think about is advanced data security platform. And what's key about this is, as I said, you have persistence, which means the controls are always going with the documents, and you have consistency, for the same reason. So I have the same policy on that document regardless of its location. So if we look at the top row there, when people think about security, they really think about, or data security, they really think about it in three areas: at rest, in transit, and either in use or in access, depending on the organization's definition. At rest, there are a lot of technologies that will do that, and all cloud providers will tell you that they are using encryption at rest. So when your documents are sitting inside their cloud, they are protected. In transit is the movement of that data. So everybody is using some type of a TLS protocol, where they're moving things around with a browser, or people use VPNs to control, the tunnels that move between your endpoint and some other location of the data. So that protects the data in transit so somebody can't hijack it. The third pillar is access. Once a user opens up a document, what does that user have a right to do? So if I have a protected document that might have some PII in it, and I'm not going to allow somebody to copy and paste that, let's say, into an internal model or into an external tool like a ChatGPT, I have more control of that particular information. And then, as I had mentioned earlier, we want to make sure that we have auditing and monitoring of what's going on with that data, because there's a variety of things we need to understand. One is who is using the data. We also need to understand the relevance of that data, and is it valuable data? So if nobody has touched that data in 5 years, maybe it's not the kind of data that we want to use inside our LLMs. Now, another key thing about this platform is to look at the lower row there. So as I mentioned at the beginning of the presentation, the biggest problem that organizations have with their data is probably 70 to 80% of the data in an organization is unstructured files and documents. Most of us don't know what it is, we don't know where it is, and we don't know its value. So there needs to be some kind of a way to find that data and then help you define its level of sensitivity. And some of that's easy. If there's PII in there, that's very simple to define. If it's intellectual property, again, it might be easy to define depending on where it is or other characteristics of that data. So as you're searching through that information and defining that really good metadata, that helps you to determine what is of value. And then as we move along, we want to be able to protect it with some kind of an advanced encryption mechanism, which is going to control who can access it, what they can do with that data. And then as we move that forward, we want to make sure that we are always understanding what the data is, who is accessing it, and the value of that data. So at Fasoo, we have a lot of different capabilities as part of our platform. You can see there on the bottom, we have some of these elements that I've been talking about. This content ID or persistent ID is a way to easily manage the metadata that is around these particular documents so that you can then get a better understanding of what is relevant data and what is valuable data. So as you are creating an AI-ready data infrastructure and you're working towards an AI-ready data set, this gives you a lot of visibility into what is of value to you, and then you can use that as part of your models. As the data comes out, this is another thing that I had mentioned earlier. If information that's coming out of the models is now becoming very important to your organization, so it is now deemed sensitive, then as you're creating documents with that data, you want to understand if it's sensitive, classify it, and protect it. The policies are another key thing that I had mentioned earlier. So you want to have consistent policies as you are managing your data. And you always want to understand, again, with some kind of an audit trail as to who's accessing the data and is it of any use to you. So here's an example of a use case that we had with one of our customers. This one happens to be in the legal industry, but this could be any organization in any type of an industry. We'll just kind of talk about it generally. What they had was any legal organization, either, could be a legal department in a corporate environment or just a legal law firm. The biggest concern they have is that they cannot expose sensitive data outside of the firm to members of the firm who should not have access to it, and clearly not to competing organizations. So if you're a law firm and you're working with Coke and Pepsi, you need to make sure that the information is not available to be seen by anybody other than somebody that's authorized. So one of the challenges they had was there was a concern of risking this sensitive client data when they were using AI tools. And again, it was a combination of things. So there were internal AI tools that they were developing, but they were also using public tools. So what they wanted to make sure is that they knew who would be either attempting to do this or who maybe did it, and they needed a consistent method to control both the inputs and the outputs. So the thing that they did was they looked at all of that internal data they had, and they classified it as to level of sensitivity, and they put these access controls I was talking about it prior to them trying to use any of these AI tools. And then what they could do is, as part of the input and the output controls that I mentioned, they would be able to tag and trace anything that was generated by the AI model, because it was producing, in this case, documents. And so they could trace these things back to the original source, and they could monitor all of those interactions. So part of the process was to go through an exercise of determining what was valuable and classifying it and controlling it as such. And then once they did that, it was a lot easier for them to have that control that they asked about. What this allowed them to do, again, I had mentioned contracts at the beginning. A lot of what goes on in the legal industry is based on contracts. And so what they wanted to do was focus on that piece of it, and then subsequent focus was going to be on ensuring that as attorneys and paralegals were using the AI tools, there was a good control there. One of the key pieces that is in the legal industry is that, at least in the United States, attorneys by their bar associations have to maintain what they call professional accountability. So if you're an attorney and you were to leak data from client A to client B, you are personally liable. So it's not just the organization, but in this case, the individual. So that is a simple example of how this law firm did that. So to wrap up, if you look at an enterprise AI architecture, these are kind of the methods and the components that you will have. So if you look there in the lower left corner where I have cloud, whether it's cloud, you have documents in your cloud, or if you have documents on premise, that's typically the data that you're going to be feeding into your models. And part of the process is that there are databases that will then index all that data. Then that feeds into what is called a RAG, which is retrieval augmented generation, which is an approach that allows you to take data in the form of documents and train your LLMs. Now, whether it's a private or a public, and I said in the case of a private tenant in something like Copilot, I consider that sort of pseudo-private because yes, it is your own private tenant, but it is a public corporation, Microsoft, and we're not all sure exactly the way that they are using that information. The LLMs are then going to be used by users, and in the newest iteration of what a lot of organizations are trying to get into is what's called agentic AI, which is there are a lot of agents that will now use that data to assist, either could be a customer service person or it could just be going out and performing actions based on that particular data. So this is kind of a typical architecture that you might use. And Fasoo has the components to address each of these areas. When I was talking about the persistent identifiers, finding the data, determining what is of value, eliminating redundant, obsolete, and trivial data, that's the tool set that we have over on the left. We do have an LLM product that organizations can use as part of a private LLM, and we have ways to help optimize that for businesses. And then on the output side, we have a set of tools that can help, on the input side and on the output side, to be able to help control the data that goes inside and then helps you control that data that goes outside. So with that, I will wrap up.